In a previous lecture, I talked about the shift from an Earth-centered system to a Sun-centered system, or what we call the solar system. Our world has a common system for space and time. Everywhere you go, you can be located by the worldwide standard of longitude and latitude. And we have worldwide time zones, so that from anywhere in the world, someone can say, "It is 9 p.m. in Cindy." But in the 15th and 16th century, none of those systems existed, and even the utility of those systems was hardly evident. The answers that Europeans developed to when and where form the basis of the scientific revolution. Why do we need to know what time it is? We regulate time because we have tasks to do. Some of them are agricultural, time to plant and harvest, and some of them are ritual, like a time to pray. For instance, Christian monks established a cycle of 7 daily services to continually worship God. Islamic worshippers established 5 daily times for prayer. The needs of the body and the needs of the spirit are both served by time. We also regulate time because we want to tell ourselves the history, the true story of ourselves. Kings and dynasties as far apart as Machu Picchu and Beijing link their legitimacy to signs and cycles in the night sky. And cohort groups in small African societies mark their increasing status through the process of coming, day by day and month by month, into adulthood. So time supports the tasks we think we should do and the stories we think are fundamentally true. Why do we need to know where we are? We organize our space to show what we own, like Stone Age British boundary markers for property. We produce maps and descriptions to help us get back from where we went, like the first-century Greek merchant guides to the Red Sea. And we use space to talk about where we stand in relation to the spiritual world, like the TO map I showed you previously, or this image of the heavens, which references the spiritual and physical world. There have been as many ways to regulate time and space as there are cultures to define important tasks and important relationships. That last point is very important. That is, what do we think is important and good to do? Common solutions form around common problems, just as we saw in the case of the printing press. And solutions are often built by creative people out of the existing solutions to other kinds of problems, like creating oil-based printing ink in an environment filled with oil-based paints. But just because some group of people defines a task as important and good doesn't mean that they will always be able to carry forward the technology for those tasks. These 3 images give a spectacular illustration of the uncertain relationship between social need, individual creativity, and technological progress. Found in 1901, this device was dredged up from a Greek sponge bed near the island of Antikythera. It's called the Antikythera mechanism, and it appears to have been made sometime around 200 BC. It lay in a Greek museum as a curiosity, mostly unremarked until 1974, when a British scholar, Derek J. de Sola Price, having analyzed at length the shape and what little writing could be seen, published a paper arguing that it was some kind of geared calculating machine. A geared calculating machine in 200 BC? No one knew what to do with that idea. It seemed highly speculative. But 30 years later, scholars took a second look at these fragments with a CT tomography scanning. They were astonished. De Sola Price seemed exactly right. The inscriptions matched an observed cycle of lunar movements. The machine would have had at least 30 precision hand-cut bronze gears. It appeared to track the elliptical orbits of the moon and possibly also the calendar dates of the Olympic Games. In struggling to understand what this device was or what it did, a number of models have been made, one of which I've placed on the right. Scholars and scientists realized they had evidence of something that wouldn't be replicated in sophistication, the machining and the calculating, for almost 1,000 years. What do we make of this? To survive and be passed from the craft secret to common knowledge and common use, technology needs momentum. It needs to address some kind of perceived need for a group to able and willing to impart its view of the world to others. What do we mean by the scientific revolution? One of the things that we do not mean is a turning away from God or a new explanation for the creation of the world around us or a new explanation for who we are as human beings. Those are later developments. The European contributors to the scientific revolution were, mostly, Christians by culture or by personal belief. What we do mean by the scientific revolution is, first, the belief that controlled experiments in the natural world and observations of the natural world, experiments and observations which could be replicated with the same instruments, established truth about the physical world. Second, these ideas and the schemata for these instruments needed to be published for human society everywhere to advance. Craft secrecy should be abandoned. Third, national associations should record, support, and share these truths. To the extent that scientific knowledge was practical, in particular to making ship travel safe, kings and merchants aligned their interests with the men who established these societies. Galileo is a familiar symbol of the scientific revolution. There are many known and unknown people who contributed to knowledge of the natural world, but Galileo's range of curiosity, studies, and discoveries give him preeminence. Galileo was born in 1564, after the Peace of Augsburg, and died in 1642, before the end of the 30 Years' War. In other words, he lived during the time that the Catholic Church was defending itself from innovation and intellectual attack. His father was a lute player. He held the chair of mathematics at the University of Padua, and later the non-teaching position of professor to the Grand Duke of Tuscany, Cosimo I. Cosimo came from a more distant line of the de' Medici family, and he not only consolidated the art collections of his ancestors in the Uffizi, which is offices in Italian, but he also became a patron of the sciences through his support of Galileo. Galileo was a contentious man, constantly in a wrangle with someone, and since most educated people of his day were in the church, constantly in a battle with one or other of churchmen about mathematics, or the moon, or the theory of the solar system. Late in life he was condemned by the Catholic Church, and lived the end of his life under house arrest. He had 2 daughters and a son, and both of his daughters became nuns. There are 3 essential instruments that changed the world from the one Galileo lived in to the one we live in. They are the clock, the telescope, and the microscope. Instruments that measure time and space. Galileo was involved with all of them. His work with a pendulum established that objects fall at the same rate. His work with a telescope helped to establish that we live in a solar system, that the moon has mountains, that Jupiter has moons, and that the Milky Way is a band of thousands of stars. He also helped to develop the compound microscope. Stepping back for a brief moment, the clock was invented somewhere around the 1370s. A town clock was a way for towns to organize themselves around working hours, to demonstrate that they had both the money and technology to support a large and grand expenditure, and to connect themselves with the merchants and routes along the major thoroughfares. This, the Prague astronomical clock, built in 1410, is among the oldest working medieval clocks. The ability to determine exact latitude and longitude came after 1764, when Englishman John Harrison built a clock that would keep accurate time at sea. Sailors could at last know how long and how far they had traveled, and avoid dangerous landings. World time zones were established in 1883, after the railroads brought far distant spaces together. These links between time and space, however, were far in the future. The 24-hour day with equal hours was established slowly across Galileo's lifetime. The clock's pendulum and escapement were inventions that lent themselves to a mathematician interested in establishing the facts about physical motion. Galileo had many friends among the universities and at the papal court, but when he argued that the earth revolved around the sun, the Italian church and scholars saw this as unsupported by facts and as a threat to the centrality of man in God's universe. In 1610, Galileo published The Starry Messenger, in which he recorded his sightings of the moons of Jupiter. Copernican theory was condemned in 1616. Nevertheless, in 1632, Galileo published Dialogue on the Two World Systems, which quite clearly supported the Copernican theory. Pictured here is a model of one of Galileo's original telescopes made by himself. He had spent nearly 22 years looking through a telescope and thinking about what he saw, most of which no other human being had ever seen. The same was true of the microscope. Those who wanted to use the instrument had to make the instrument. Few had the expertise. No one had ever seen a flea up close, or the plaque between someone's teeth, or hair, or sperm, or what lives in a drop of water, or all of the other random and miscellaneous ephemera that were excitedly placed beneath the scope. As the first illustrations were published, people looked in wonder at a hidden world that was with us all along. Galileo used microscopes, but the more famous explorers are the Dutchman Anthony van Leeuwenhoek and Englishman Robert Hooke. Both of these men lived in the generation after Galileo. Hooke's Micrographia of 1665, which contains this illustration of a flea, shared what he had seen with the Royal Society of London, founded in 1660, around the same time as the French and Italian scientific societies were founded. So what should you remember and what should you keep thinking about? The idea of the scientific method, of experimentation and observations with instruments supported by mathematical descriptions, was first expressed in the Counter-Reformation. It was carried forward by men and women in universities and supported by a stream of publications using the media of the printing press. The big ideas of the day, the position of the sun and the generation of life, were debated by every thinking person and every powerful institution of the day. Galileo is a founding figure, a person who embodies the controversy and the courage needed to express profoundly different ideas about the physical world. I showed you the Antikythera mechanism to illustrate the point that technological progress is not inevitable or linear, although commonly perceived problems and useful solutions are carried forward by influential groups within society. Further, I argued that the development of GPS, of Google Earth, which is the source of this image, and of the many tracking devices we now use freely, come from the totalizing mentality of seeing the world as one whole place upon which any single point can be mapped. The system we live in was built because of the clock and the telescope, and it now depends on the further inventions of the camera and the satellite. I am wondering, and I think it is worth wondering, what will be the next instrument that captures and expresses our ideas about what is good to do with time and space.